color attribute dot set. Okay, see. Oh, good. Author inside the variant. Okay. So variant is created from variant set via get variant and used within a block while the
Okay,
contextual
we are live.
from attribute the author go inside the selected variant, so they only apply when the variant is active. That tells you is ready to block the user and after the prevent general without a way. Okay. I see. I see. Okay. Variant edit context is done. USD light USD lights.
We are live.
Yes. USD distant.
X1. Okay.
Transformable. Alright. Okay. Let's see where we are.
What? That happened.
All usually looks from type transform because we are derived from geo. License. This given as a light and wave something like geo defined function types to USD lux. They are counting types here first of all. USD lux is sometimes USD lux pure light okay. USD lux. Color position they have better intensity with color attribute okay color better resolution okay I see.
X form, light, and visualization. Okay, so they are starting with schemas. So I'll quickly read this part on this. Okay. Schemas give meaning to the prim in OpenUSD. That is, what is the element? What is this element? Okay, what capabilities does it have? Schema defines your data model and optional API for encoding, interchanging 3D or non-changing non-3D concepts. What are schemas? Schemas serve as blueprints that author and retrieve data like attributes and relationships that govern behaviors, other elements in USD scene. Each prem in scene is an element that implicitly contains the properties and fallback values that are values of type schema that's telling the prim what it is. For example, the radius attribute of the sphere schema is defined as double radius equal to 1, meaning that all sphere prims have radius represented by double precision floating. Okay. Oh shit. Damn. Okay. We know that there's a trend towards cordless schema easily suggesting the schema might become more lightweight, focusing on data modeling rather than behavioral.
Close.
This is allows for flexibility, performance optimization based on different use cases. There are the schema and also known as type schema or prim schema. Essentially tell the prim what it is. Okay.
Yeah.
Type.
We try to finance and we are used to the class of release class of all.
Type name metadata assigns as a schema to prim is a schema derived from the core class USB type. Is a schema derived from the core class USB typed, the base class for all typed schemas. Okay, which is why we here is a schema is referred to as typed. Okay, these schemas can either be concrete, instantiable, or abstract, non-concrete, served as base classes. So this was one of the questions, concrete and abstract.
Yeah, yeah. Concrete and abstract, instantiable and non-concrete served base class.
Instantiable, non-concrete. Okay, so this concrete is instantiable. Abstract is serve as base classes. Serve as base classes. These schemas can either be okay. A schema is concrete when it can be instantiated as prims in USD scene, as we see with USD geom mesh and USD geom scope. Concrete schemas provide both a name and a type name in a schema definition. Provide name and type name in schema definition. Abstract or non-concrete schemas provide a name but no type name. Provide name but no type name. Okay. Um, USD geom point based. Okay. In the schema definition, this enables them to serve as base class for related sets of concrete schemas. The way USD geom point base serve as base class for geometric objects that contain points like meshes, USD geom mesh, or basis curves, USD geom basis curves. Okay. Base class for geometric objects that contain points like meshes, USD geom mesh. So what does this basically mean? Serve as base class.
Base class means over here like a class that from where you can initialize other methods or APIs of the same class.
But then
So
will it not become the same? No, bro, that I don't think that's.
why would it become same?
If so, what does it? Okay, so it is saying provide name but no type name in the schema definition. This enables them to serve as base class for related sets of concrete schemas.
Yes. So
Yeah,
do you know USD Lux?
yeah.
USD Lux is a base class. USD Light is a base class, and USD Lux distance light
Hmm.
is a concrete schema over here. Why?
But how do you know? How do you know that?
Because USD. How do you know? What do you mean by that?
How do you
Like,
know
because
that it's an abstract or non-concrete schema?
because a base class would have a lot of functionalities like get attribute, create point attributes, and other things that a main class won't, a concrete class won't have. The goal of concrete class is to have certain kind of definitions that are only provided
But
for that class.
if you're asked how, okay, if you don't know like what is abstract, what is concrete, and you're asked USD geom mesh and USD geom scope versus
Mhm.
USD geom point based and USD geom basic curves. Okay,
You
wait,
can
like yeah, how can you differentiate then?
you have to remember it, brother. You cannot differentiate. Like you have to recall everything. So that is a tough one.
Let me. Where is my fucking? Oh yeah. 'Cause I'm still standing, looking like a true survivor. Okay, let it answer that. In the meanwhile, we'll read API schemas. In addition to user schema, we have API schemas. API schemas are similar to user schemas, except they do not specify a type name since they do not have type name. Yes, since they do not have a type name and they are considered to be a non-concrete. Or so I have a doubt. So there are two types of is the schemas, right? There is concrete schema and there is abstract schema.
Yes.
And then the API schema, in addition to is a schema, we have API schemas. API schemas are similar to is a schemas, except they
Mm-hmm.
do not specify a type name. Since they do
Mm-hmm.
not have a type name, they are considered to be non-concrete.
Mm-hmm.
And abstract schemas are non-concrete schemas.
Mm-hmm.
So API schemas is a type of a- abstract schemas, which is a type of is a schema, or is it
Ab-
just?
so abstract schemas are something that you cannot change. Like abstract schemas are defined directly
I
inside.
know that. I know
Yeah.
that. What I'm asking is over here. This is directing that API schema is a non-concrete or abstract schema, right?
Mm-hmm.
And abstract schema is a type of is a schema.
Mm-hmm.
So
But
base.
abstract schema. Yeah. Go ahead. Go ahead. Go ahead. Go ahead.
So API schema is also a type of is a schema.
No, API schema is not a type of is a schema. API schema is a different schema. Is a schema is a different schema. API schemas are a different schema.
I know that. I know that. What am I asking? They are considered to be non-concrete, right?
Mm-hmm. Mm-hmm.
And abstract is also non-concrete.
Mm-hmm.
So why are they same? And
Go
if
down.
abs
Go down. Look. Read the second line.
okay, API schemas are typically named with suffix API. I know that, such as yes, properties that belong to API schemas are namespaced with schemas base name and camel case. For example, USD physics rigid body API create velocity attribute will create an attribute name physics velocity. API schemas can be classified as non-applied or applied, and single apply or multiple apply. What does and mean? Like these are two categories and these are also two categories.
Yes. They can be
Single
both.
apply.
They can be both. They can be non-applied and a single apply. They can be applied or multiple apply, or they can be applied or a single apply. Whereas is a
How can
type
it be
schema
non-applied and single apply both?
depends upon how are you applying. So you can apply a non-applied schema to multiple prims as well, and as well as to a single prim as well. So it depends upon the user how it is trying to apply it. Like it's more of a hands-on learning thing. That's why like we are confused over here. But this is the standard typical definition of API schemas.
Mm-hmm. Single apply API schemas are applied to only one single instance of the prim. Multiple apply API schemas can be applied multiple times to the same prim with different instance names. So, like it is used in instancing. For multiple apply, it is used in instancing.
Yes.
Same prim with different instance names. API schemas are applied to only one single instance of a prim. I need to understand this, bro. I don't know. Okay, unlike as a schema, API schemas do not assign a type name to a prim. Yes, instead they are list edited in API schemas. Yes, they prepend API schemas equal to do that shit in metadata and are queryable via the has API method. Queryable via the has API method. Okay. Oh, I think this was a question today in the thing as well in the quiz.
Mm-hmm.
It was saying that physics API. How will you check if Prim has a physics API as its schema?
Wait, what? What was the question again?
Physics API, like physics schema API or something, USD physics API. Uh, like we needed to check if the Prim had that schema applied on it, and the options were to choose from like a Python function.
To choose from Python function.
Let me see
I
if I can see that question over here. I'm still standing. And I think I got it right.
because I know every other.
No, 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 no. Like the options were confusing. Like they were same.
Hmm?
HD Stone Wall. Yeah, this one. This one.
Yeah.
This one.
A developer needs to confirm at runtime that USD physics body API has been applied to a prim before safely querying its physics velocity attribute, which Python call is correct. So, what were the options? USD physics rigid body API get path, so that is definitely eliminated because we need to find out about the attribute. B prim dot has API USD physics dot get rigid body API. B is also eliminated. It verifies web. C prim dot velocity and prim get property names, and then it's gonna be what has been applied before. In a runtime that has been applied to prim before safely querying it to confirm runtime has been applied to prim before.
I think the answer would be B over here. I think mine is wrong.
Would be okay. Just ask what does Cloud Code says over there. Why would it be B prim has API?
What do
So
you? What's your answer?
it needs to confirm at runtime that it has been applied to a prim before safely querying its.
I think it should be B.
With process of elimination, B would be the most appropriate one. Because
No, bro.
type,
By the process of elimination, D would be the most appropriate
why would
one.
we process by the process of elimination? D would be the, why would you want to know type name? Because the question asks, it needs to first verify that uh, is the rigid body API has been applied to that or not.
Answer
Why
should
are
be
you
B. Yeah, answer should be B now
why
that
are
I've
you
read that.
looking, no, but why are you looking for type name first of all? That would be my question.
Okay, okay. 60 is B. Yes, I was right.
Like type name,
Has API.
and this is the same thing that we read over here, so
Yeah,
that's why
this one.
it has
Queried
API.
with has API. Okay, I think ChatGPT gave some explanation over here. Hmm. Abstract schema is parent category slash shared behavior. Concrete schema, the real thing you can author as a prim type. Parent category, base class, the parent schema. A new schema inherits. Who the Let's always do a lot of good. Who the hell? I don't know, bro. Some weird ass motherfuckers in the chat. Always
Was
some weird ass.
was that weird ass motherfucker in the chat doing?
Oh, oh, he's writing. Let's always do a lot of good.
Okay, dude, I have a question for you.
Or
Right. So you have a sublayer A,
yeah,
right? In that sublayer, there is a specifier mentioned,
mhm.
depth cube,
Def cube. Okay.
and it has no opinions.
Yeah,
Then you have sublayer B.
yeah.
It has an over specifier mentioned, and inside that over specifier,
Mm-hmm.
it is mentioning def sphere,
Uh,
right? So what would be the output when you compose it into the root trim?
what would be the output?
Yes.
Output of what? Like if that is not inside root, like if they are not defined inside root.
They are defined defined inside the root as sublayers. So first sublayer B is defined, and then second sublayer A is defined.
Yeah, but for any stage to like compose an
No, no, like
element, they should.
what would sorry, my bad. What would you see in USD view when you compose the prim? What will you see in the USD view?
But I my question is are they defined in the root layer? Like if they are not present in the root layer, why would anything would be composed on uh like on the
Wait.
stage?
I think I'm missing something, but let me just verify once.
Show me the question. Like where is the question?
Yes, brother. Yeah, this question was really good and interesting, and I got it right. So, but anyways, let me see where it is. Let me see.
Beep beep baby. Come on. Beep, beep, beep.
Okay, yeah, there we go. Oh no, I did got this wrong. My bad. I did not got it right. So yeah,
Mhm. What is the question? But
yes, brother. So, a root layer composes two sublayers.
Mhm.
In sublayer A.USDA, the geometry contains a def for cube. In sublayer B.USDA, geometry is an over that adds a def for sphere.
Yeah.
The root authors its sublayer as shown, where the first appended sublayer has the strongest opinion. When the cube is selected in the USD view, which layer appears in the layer stack, and why does the over in the sublayer not erase the cube?
Show me the question, brother.
Yes, brother. If I share my screen, I think it might fuck up your stream.
No, it won't.
Are you
Yeah,
sure?
you just need to share it on Video Ninja.
All right, there we go.
Yeah. A root layer composes two sublayers in sublayer A.USDA. Uh, Geometry contains a def for cube. In sublayer A.USDA, geometry contains a def for cube. In sublayer B.USDA, geometry is an over that adds a def for sphere. And defines a sphere. Okay. The root authors its sublayers as shown, where the first appended sublayer has the strongest opinion. Okay, append is at the back. Okay. Uh, when cube is selected in USD view, which layer appears in its layer stack, and why does the over in sublayer B not erase the cube? Sublayer in what? Neither layer appears for cube. Over is stronger in sublayer B. Deactivates the cube because over does not define a prim. Both sublayer B and A appear for cube as an over is neutral override container that does override container that does not change the resolve. Just sublayer A.USD appears for cube and def for cube in sublayer A.USD. Geometry contains what is that? Okay, geometry contains a def for cube. And over in stronger layer. Okay, when the cube is selected, which layer appears? Layer is discarded whenever def exists for appears for cube. The stronger over and over is what? Over that adds a def for sphere. I think the answer should be C, but wait. The stronger over specifier replaces the def and reroutes the cube's definition. But it is a sphere. Geometry is an over that adds a def for sphere. Yeah, I think C.
No, brother, it's B. I also thought C, but it's
D.
B. B for ball.
B.
Yeah, B.
Both sublayer A and B appear for cube, and over is a neutral override container that does not change that resolved def specifier coming from the weaker layer. Okay, makes sense. I see. So,
Because an over is a non-defining specifier, a container
okay.
for override opinions only. So
Hmm.
you can only use over for opinions, not for any other thing. So you cannot have nested specifiers.
But why
Uh,
would sublayer B appear on that if it is not even giving any opinions?
but sublayer B already so there it's not about opinion. It's about that prim. It's
Mm-hmm.
about that because you have to go back to the fundamentals. First, you are defining layers. So when you compose a prim, each and every layer gets composed in.
Mm-hmm.
That is the most important thing over here. So they will be definitely composed individually, and both will be seen accordingly. The main question was will over affect it, but over is not going to affect at any point because over is a non is a neutral specifier and
Mm-hmm.
not, and it acts as a non-identifier. So if you define a prim with an over specifier, USD won't compose it. Similar to like class. To define a prim, you have to always use def. That is the most important concept for specifiers. And over is also weak as specifier as compared to def.
Both sublayer B.USD and sublayer A.USD appear for cube, and over is a neutral override container that does not change the resolved def specifier coming from weaker layer. And the question was, when cube is selected in USD view, which layers appear in layer stack, and why does the over in sublayer B not erase the cube? Which layers appear in the layer stack? Okay, okay, got it. Beep beep baby. All right, okay, we can come back to this. It's already one. Okay. In USD schema language, think of it like this. Concrete schema. Concrete schema is something you can directly create a prim type in USD. Def mesh body here. Mesh is the concrete type schema because you can actually author it in USDA file as a prim type. Okay. Other concrete examples: XForm, mesh, cube, sphere, camera, scope, material, shader. Okay. XForm, mesh, cube, sphere, camera, scope, material, shader. Okay. USD geom dot mesh. USD geom dot mesh. USD geom dot xform material. Okay. Define. These are concrete because they represent real authorable prim types. Concrete schema can appear after def in USDA, def xform. Okay. Abstract schema. And abstract schema is not something you usually author directly as a prim type. It mainly exists to provide shared properties and behaviors to other schemas. USD geom imageable, a thing that can be imaged or rendered and has properties like visibility and purpose. Many concrete schemas inherit from it. Okay, so API schema is something from which a concrete schema inherits.
API schema is something from which concrete schema inherits. It
Yeah,
can, yeah, it can.
it is, not it can.
Many
That is
concrete.
what is called a base class like thing that you are saying. That is
Yeah.
why abstract schemas are a base class.
Yes.
That's what I think. So imageable is like a parent category. Okay. USD geomics formable. This represents the idea of a thing that can have transform ops. Okay, USD geomics formable is another API schema, a thing that can have transform ops. Concrete schemas like XForm, Mesh, Cube, and Sphere inherit XForm behavior from it. Okay, so def XFormable thing. You usually do not write def XFormable thing. You write def XForm thing, def mesh thing, and those concrete schemas inherit behavior from abstract schemas. Abstract schema is equal to cannot usually be the final authored prim type. It is usable parent category. What base class means here? The parent schema class that your schema inherits from. Yes, that is what base class means. Okay, now I get it. It answers what kind of schema am I building? USD schema based, basically. Okay. Big identification rule. Is this schema creating a new kind or of a prim? Or is it adding behavior or properties? That's how you differentiate, bro. If
Well,
if a schema is creating a new prim, then it's a concrete schema. But if a
hmm.
schema is adding some new behavior or property to an existing prim, then it's
Mhm.
an abstract schema.
Oh, I see.
I wish we have an interview where people ask us about OpenUSD now.
For sure.
That
For
would be
sure.
insane.
for sure.
I will impress people now.
I think they would be much more interested in
What we
what.
built.
Yeah.
Instructs incoming. Instructs 2.0. After a big defeat from A16, we speed run. Case a new prim type. If the question says create a new type of prim, define a new scene object, ask author a def. Okay, then you are typed slash concrete schema. Territory typed. Okay. Case we add properties to an existing schema. You're in an abstract schema. Mm, API schema territory. What? API schema. Simplified. USD schema based. USD typed. USD API schema base. Abstract, concrete typed. Okay, so this is the mental map, bro. Look at this.
Typed geomeasurable, geoformable, geomexform, geomesh, then geom API schema base. Material binding API and then custom. Okay, but they're typed names and APIs are not typed names. Abstract is also typed name. So you're saying abstract won't initiate any new prim, right? Or abstract will initiate
Bro,
on
that
top.
is what I was asking over there. That is why I was asking if abstract is similar to API schema or not.
Yeah, that's what I'm saying. Abstract won't initiate any new prims.
Yeah, abstract won't initiate any new prims, but
Or is it?
concrete would. Concrete would.
You sure?
Yeah, concrete would initiate new prims.
Will abstract initiate new prims or concrete would initiate new prims? No, dude. Wait, yes, yes. Abstract won't. Abstract won't. Yes, yes, yes. Abstract won't. Only indirect.
Material binding prims. But wait, there is more. In addition to user schema, we have API schemas, blah, 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 blah. API schemas can be classified as non-applied or applied API schemas and single apply or multiple apply. Categories. Non-applied or applied and single apply or multiple apply. Single apply or multiple apply. API schemas are applied to only a single instance frame, multiple apply. So I'm guessing it is non-applied. Applied. Okay, meaning mesh is concrete, but mesh inherits behavior from abstract parent prims, so mesh can be treated as mesh and okay. Example, mesh is concrete, geomex formable, and imageable are abstract. Repurpose, use transform concepts like SOMOP, use the imageable, boundable gives. So I think one hack to recognize an abstract or base schema is something like able, something ending in able, like imageable, exformable, boundable. Um, because
Yeah,
this is what is an abstract schema. This gives like new properties, which is from which like a concrete schema would inherit. And usually geo mesh like single is concrete.
I see. Abstracts are able. Hmm.
Yeah. Concrete schema, the actual type mesh, abstract schema, the inherited categories that give its shared behavior, how to identify in a question. Define a prim, new prim type name is a schema, can be authored as def. A answer is concrete typed schema, USD type. A studio wants a new prim type called robot joint that sounds like a concrete typed schema.
I see.
Look for these words in abstract base class, common behavior, shared properties, parent schema, not directly instantiated, inherited by other schemas, likely answer abstract schema. Okay, add properties to existing. Okay, so to add properties to existing prims, apply to geometry prims, non-standard attributes, attach behavior, prepend API schemas. This is the API schema. Okay, add physics. Okay, not API schema. So, how are applied schemas different from API schemas?
Dude, APIs, applied schemas are part of API schema.
No. Oh, sorry. Fuck. Abstract. I was. Yeah, abstract schemas different from API schemas. Mhm. Abstract schema and API schemas are both not usually authored as primitives, but they are different mechanisms. Abstract schemas inherited parent class in the typed schema hierarchy. API schemas extra behavior properties attached to an existing prim. Okay. Mesh is an imageable, mesh is exformable, mesh is boundable. This mesh also has material binding API applied to it. Ah, I see. Read this, bro. Read this whole thing. It is explaining quite well.
Schema and API schema are both not usually authored as prim types.
Inherit parent class in the type schema hierarchy, API schema, extra behavior and properties, attribute mesh is immutable, but mesh is exformable and mesh is roundable. This mesh also has material binding API and applied to it. Abstract schema is a parent category that concrete type schema inherit from. An abstract schema is parent category that concrete type schema inherits from. Okay, okay.
So when you write def mesh, body mesh is concrete schema. Okay. Mesh is the concrete schema, but because mesh inherits from abstract schemas, it is also gets shared behavior like imageable, visibility, purpose, exformable. Uh, you do not apply those manually. You do not write the prepend API schema is exformable. Okay. Abstract schemas are part of the inheritance chain of the concrete typed schemas. Add extra behavior. Add extra behavior or properties to an existing trim. Okay. Without changing core type. Body is still a mesh, but it also has material binding API. The API schema is like a plugin capability. It also has material binding API applied. The API schema is like a plugin capability. Does not become a new prim type. Family inheritance, optional batch capability. Okay, look at this. Abstract schema is family inheritance. API schema is optional batch capability.
Mm-hmm.
Okay. Pick comparison table. Is it parent base? Yes. No. Add on inherited by concrete schema? Yes. No. Applied separate. Does it appear in? No. Yes. Does it define a prim type? No, not directly. No. Look at this. This is what you are asking, right?
Does it define a prim? No, not directly.
Abstract
Uh,
schema.
But concrete schema would initiate
This is
only.
API schema, not concrete.
No, but I'm saying what concrete schemas
Yeah.
would initiate prim.
Concrete schema will inherit from abstract schema, and then concrete schema is going to define the type of prim.
Yeah.
How does a prim get it? Through its concrete typed schema inheritance. This API or using the API helper. Material bounding API, XOM common API, USG unboundable is a relationship, has a capability. Example, describe an optional library. I got it. Now, similarly explain the difference between non-applied and applied and single apply and multiple apply. Applied API schema. It's crystal clear now.
Mm-hmm.
No question will be skipped in the exam, bro.
Either the option of elimination would be used to resolve the issues.
Brother, they are not gonna use Claude Code to generate options. I don't know
But still,
what if bro what if they do the same shit that we are doing and we get exactly the same questions.
no, bro. We can try one thing. We can we won't use Claude. Okay, but Jensen Huang itself said that they are using Anthropic's Claude code heavily.
Mm-hmm.
I don't know if they would have generated with the same thing.
Mm-hmm.
They might, but they we can also use their own model, Nemotron Ultra,
Mm-hmm.
to create some of the quiz. Maybe we get the same types of quiz from them as well.
Maybe. Okay, API schemas that are applied to only single instance of a prim. Multiple apply schema is API schemas that can be applied multiple times to the same prim with different instance names. Unlike as a schema, API schemas do not assign type name to the prim. Instead, they list edited in the API schemas metadata. I see. API schemas do not assign a type name to a prim name. Instead, they are listed in the API schema metadata are queryable via has API method. API schemas are assigned to already typed prims to annotate them with additional properties that govern behaviors. Oh shit. Retrieve. Okay, so has API. One API schema is list edited in API schemas. List edited in API schemas. Queried with queried with as API. Layered onto an already typed from worked with Python. Retrieve the schema info for registered schema. Schema.retrieve. The schema info. Schema registry. Find schema info. Type USD schema registry.
GTA.
You can hear that.
Yeah, bro.
Damn. schema type. It's New York, bro. Gotham. These methods allow us to interact and manipulate schemas programmatically, enabling us to create, modify, and validate USD assets based on predefined rules and conventions. Is a schema example USD geom sphere. Yeah, okay, USD geom defines the schema for representing geometric objects such as meshes, cameras, and curves. It also includes schemas for transformation, visibility, and other properties. Import related classes sphere equal to USD geom not sphere dot define stage. Okay, is a schema USD lux disk light. So USD lux defines the schema for representing light sources in a scene. It includes schemas such as sphere light, disk light, and distant light. Example include in USD lux disk light, USD lux rect light, USD lux sphere light. These schemas bring properties relevant to each light type. Examples include okay, discrete sphere. These schemas bring properties relevant to each light type, radius. Okay, these attributes in combination with attributes defined by light API schema. Example allow us to fully define a light. Okay, so disk light is equal to this USD light disk lux disk light define. Get all attribute names that are part of disk light schema. DL attributes. Okay, get and set radius for intensity. Okay. Notice radius comes from disk light, typed is a schema, while intensity comes from light API schema, a concrete illustration of how typed and API schema's properties combine on one prim. I see API schema example, USD physics rigid body. USD physics rigid body API has physics properties too, any USD geometric formable object. So this is gonna be an abstract schema, and this is gonna be an API schema object for simulation such as rigid body dynamics. So Pixar, USD, physics, rigid body, apply. Okay. So okay. Also another thing in a is a schema when you are defining a prim using an is a schema, you're gonna use things like dot define, and you're gonna define it on a path and on a stage.
Yes,
But for APIs, you will usually use dot apply and you'll apply it directly to the prim.
because ISA schema helps you to create new
Prims
prims.
and a abstract API schema applies it.
Yes, schemas are adds helps you to add properties
Hmm.
onto the existing prims. I would say that's why like rigid body API dot apply cube dot get prim. So you're basically applying a new property over an existing prim rather than creating a new prim. In the above, you're defining a prim. So basically, you're creating, hey, I want to create disk light prim inside world light prim. So that is the major difference I see in the syntax over here.
Hmm. Bro, I'm such a fucking genius. This example shows how API schemas can be applied to this govern behavior, such as adding rigid body capabilities to an object hierarchy. Note that API schema workflows dot apply prim to add it versus is a schemas dot define stage comma path. Wow, bro.
Wow.
I'm such a fucking
Wow.
key takeaway. Schemas OpenUSD servers template defining prim. These are two distinct types of schema, blah 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 alongside extensible. Now I'm like crystal clear on schemas, bro.
Hmm.
And then one thing. And now it is X form. Okay. Yes, these are three related ideas inside API schemas: non-applied API schema and applied API schema. And applied API schema is of two types: single apply and multiple apply. NVIDIA, blah blah blah. Non-applied API schema, it gives you a convenient API to read write known properties, but it does not record itself on the prim. This author's normal transform properties, USD. Oh, bro, what the hell? No mas. Mm-hmm. Okay, so okay, do you understand the difference between non-applied and applied then?
Applied and non-applied schemas. I think, as if I recall, in applied schema, we do not put the name, right? Or do we put the name inside? Like we can put a custom name in an applied schema, and in non-applied schema, we do not put a custom name when we're trying to define the prim or define the.
What? No, bro. That
Yes,
is,
yes.
you're talking about is a schema.
No,
This
no,
is
the
inside
custom
API schema.
name. Yeah, inside API schemas. Inside API schemas, like you can. So if you're using a applied schema, a non-applied schema, you can put the name. You can put a custom name of the API in non-applied schema. That, like, I think we did saw this earlier.
Okay, wait, let me read this. A non-applied API schema is mainly programming helper. It gives you a convenient API to read write known properties, but it does not record itself on the prem. API is equal to usdgeom.xform common API. Xform API dot set translate API dot set scale. This author's normal transform properties. Def xform box. Um, double three xform OP translate 1000 float 3. Okay, but it does not author this. Prepend API schemas xform common API. USDGeom xform common API. Set scale. Okay. So there is no metadata generated for non-applied
Yes,
API
yes, yes.
schemas.
Yeah, this is what I was talking about. You see the line prepend API schemas equal
Yeah,
to
it does not author this. It does not.
which part?
This is non-applied.
So applied schemas does that, right?
Applied API schema. Wait, let me see. So the prim does not carry an applied schema mark. Oh, so that's what it means. If it is not getting appended inside the metadata as prepend
Yes.
API schemas, then it means that it's not gonna carry an applied schema marker, and that's why it's called non-applied. Okay, applied API schema. An applied API schema is explicitly attached to a prim. It gets recorded in the prim's API schema metadata. OpenUSD's USD API schema based docs say applied API schemas are useful when you need to discover or record that a prim contains slash subscribes to a given API schema. It's recorded in the prim. Doc says applied schemas are useful when you need to discover or record that a prim to a given API schema and applied API schema generally add properties to a prim. Mainly programming helper. Hmm. No API schema helper interface used programmatically. What does that mean? Used programmatically what? Like it defines like some new fields for you to input.
I guess so.
I see. Okay. Examples, def mesh, body, prepend API schemas, material binding API. Well, material binding is equal to look slash metal. Material binding API is applied to body. Kind of schema leaves a visible marker. API schema on material binding API. Single apply API schema. Single API schemas can be applied once to a prim. Define okay. You do not apply it like this. Okay. A multiple apply API schema. Hmm. Ah. Can be applied multiple times to the sample prim, but each application needs an instance name. Mm.
API schema versus non-applied API schema.
Multiple apply API schema can be applied multiple times, but each application needs an instance name. Oh, USD collection API as an example. I see. So look at this. Collection API. This is like one API schema, but it is applied multiple times on cars, trees, and buildings.
Mm-hmm.
So why is this and how is this used is over here they're defining a relationship, I guess, for collection of cars includes and then collection of trees and then buildings. Here the schema type is collection API, but the instances are okay. So so a multiple apply API schema is an API schema that is applied to multiple instances in a prim, I guess. Naming pattern for single apply API schemas. The applied name is just the schema type name for multiple apply API apply schemas. The name includes the schema type and instance name separated by a namespace delimiter. For example, collection API, plastic stuff, multiple apply API, same API schema, many named instances. Recorded in API schemas, non-applied is no, no, no. Okay. No, 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 no. Collection API. Okay. Visual memory, helper tool. Okay. I think we can start XForm now.
Mm-hmm.
XForm! Come on. In universal scene description, XForm plays a key role in defining the spatial transformation of objects in a scene. In OpenUSD, an XForm is a type of prim that stores transformation data such as translation, rotation, and scaling, which apply to child prims. This makes XForms a powerful tool for grouping and manipulating the spatial arrangements of objects in 3D scene. XForm stands for transform, reflecting its role in transforming the space in which its children reside. XForm stands for transform, reflecting its role in transforming the space in which its children reside. I see. How does it work? XForm prims allow for hierarchical transformations, meaning that transformations applied to a parent XForm affect all of its child prims. This is essential in complex scenes where multiple objects need to move or scale relative to the parent. Typical use cases include animating characters or robotic arms, or where different parts are children of an X-form prim. Hmm, I see. Do we need some more pull-ups, chat? I'll do some more pull-ups if somebody requests in the chat. No one. Okay. X form. Okay, hierarchical transformations, meaning the transformations applied to parent X form. Okay. So in Python, working with Python, you have usdgeom.xform.define stage, comma path. Retrieves the order of transformation operations, which is crucial for understanding how multiple transformations are combined. Different orders can yield different results. So understanding xform op order is important. Xform.get xform op order attribute adds a new transform operation to the xform prim, such as translation or rotation with specified xform add xform op. Okay. So you understand this, right? Xform op.
Operations, yeah, yeah.
Okay. USD geom and xform.
This is what we did yesterday regarding right to left operation.
Yeah, yeah. Oh, I did have a question like that today, but it was a different question, like a little different.
Mm.
And I want to see if my answer was wrong or right over there. Oh, this is the question that you got yesterday. I got it today. Rotates plus 90 degree.
You will get the same questions because you're using the same question bank.
Yeah, I know. But wait, I did get a question, and I was confused for like I think my answer was correct because one second, where is uniform token scale rotate? Oh, yes, this one. Look at this. Read this question.
The XForm below authored via XForm Common API. What XForm operation order does the API author and in what order are the component transform being applied? Mm, dude, I'm not able to see shit. Zoom in. More.
No
More. I'm not able to see shit.
more.
Yeah. Yeah, now good, good, good. Parent trim. Okay, rotate, scale, and translate. What in what order are the component transforms applied? A fixed order, an arbitrary order, a single operation order. Fixed order is translate, rotate, scale. No, this won't be. Arbitrary and XForm is authored in what I know, and single operation is in matrix combine, translate, rotate, and scale. And what is the other one? A fixed order, scale, scale, then rotate, and then translate. Yeah, left. Scale, then rotate, and then translate. Okay. Yes, yes, yes. Right to left. Right to left. Right to left.
So answer should be D, right?
Yeah, answer should be D.
Yeah.
But
So let
the
me.
operation must from transform. Yeah, technically answer should be D only. A single operation transform matrix combine, translate, rotate, and scale.
What are you searching?
I'm not searching anything. I'm just recalling some things.
29. Answer is wrong. A.
A.
Yeah, I don't know how the fuck this is wrong.
Translate operation. Let's ask ChatGPT the same thing. It will tell us. Composed operation like should be D.
Because I thought we were doing this scale, rotate, and translate this one, like from right to left. That's why I chose this scale, then rotate, then translate. But the answer is
No, A should not be an answer, dude. A should be incorrect. Ask ChatGPT once. Just ask ChatGPT.
I thought my answer was right over here, but it is wrong. Damn. Mm. Clarified transform order. Ah, chunky monk. Okay. Yeah, the answer is A. I think there is some concept that we don't know regarding this.
What is saying buffer the XFAM author APIs uniform, but this is a third order. Where the component transfer effects on the object is scale, rotate, and translate. It's also saying the same thing: scale, rotate, and then translate. So this
No,
XFAM,
bro. Look at this. That is
it
the
says,
third order. Translate, rotate, scale.
but the component transform effect on the object is scale, rotate, and translate.
Scale, rotate, while. What?
Go down.
The real source of truth is X form OP order. Translate, rotate. Bro, look at this. From this X form common API author,
What is the answer first? First, verify that.
that is the authored order, but the component transform effect on object is scale, rotate, and translate.
No, that will be the correct answer. So
In
that
what
means
order are the component transforms applied?
scale, rotate, translate. It won't be translate, rotate, and scale.
USD is transform. It's a transform stack order, so this means X form OP order is equal to this. So this means scale, rotate, and translate. The final transform scale, okay, no. The order the attributes appear in the file does not decide the transform. This is this order rotate scale transfer does not matter. The real source of truth is X form OP order. Hmm.
I think D is correct, bro. Bro, A is incorrect, I would say. Because it does say that how will the component transform applied. When we are talking of applying them, it will always be right to left.
Hmm. I know. It's saying USD uses row vectors and post multiplication point transforms. Ops. That kills. It's saying XForm common API's fixed stack is always translate, rotate, scale. If you see scale first, it's wrong by definition. This is the same USD geom.xformable cluster as your other two. but isn't XFOM common API. Yeah, bro, I think
Yeah, D is the correct answer, brother. Sometimes AI hallucinates. Motherfucking Claude. Wasn't that the question, right? AI hallucination, bitch. When's the meeting tomorrow?
let me see. It's probably at 12:45.
12 fucking 45.
But I need to go to the office tomorrow, bro.
Yeah, I'm also planning. Wait, when I do have an appointment tomorrow. Wait, oh, it's at 11:30. So fuck yeah, I have to also get up early.
I have to fucking wake up at 10 anyhow.
Oh really?
Really, bro, really.
Oh, really?
The XFOM of your order attribute that XFOM that is the author of with the order and that applied to point reverse to how you read this. Okay, so however XFOM OP order attribute is defined, that order is the ops are listed, but the order in which they are applied to a point is the reverse of how you read the list intuitively. A point is scaled first, then rotated, then translated over here. Yes, so we are right. In a matrix,
Yeah.
we.
That's why I created this reference thing, so that like all these kind of critical concepts, you know.
So I scored more than
Yeah.
59.
There's, I was gonna say you that don't blatantly trust on Cloud Code. Sometimes it fucks up. Like sometimes it will pick up some of my options as twice for MCQs, and then I would have to say no. I did answer them and all those things because like it uses the method of highlights. That's why. So the answer is D.
You are wrong, brother.
Then I would curse Cloud Code a bit. Fuck you. Are you retarded? And they're like, apologies, Lord.
Apologies, Lord.
Apologies.
Apology, topology.
Anti-inflammatory tablets. Oh,
Okay.
some.
All right, let's read this quickly. Okay. Exome prims allow hierarchical transformations, meaning that transformations applied to parent exome affect all of its child prims. This is essential complex scene where multiple objects need to move or scale relative to the parent. Typical use cases include animating characters or robotic arms, where different parts of children of an exome prim or arranging furniture and architectural visualization where all items in a room might be scaled or rotated together. I see a USD geom.xform.define. So this is what like it's I think is a schema. Xform is a schema. Um So retrieve the order of transformation operation, which is crucial for understanding how multiple transformations are combined. Different orders can yield different results, so understanding XForm or OP order is important. XForm dot get XForm OP at order attribute. Add the new transform operation to the XForm prim, such as translation or rotation with specified value. Xform dot add xform op. What does that do? Add the new transform operation to the xform prim, such as translation or rotation,
Yes.
uh, with specified value. So op type is transform or something like that.
Yes, operation
Xform,
type like no, OP type is what kind of operation are you trying to do?
yeah,
Is
like
it a
translate or rotate or scale.
scale? That is what OP type means over here. So you're
Mm-hmm.
gonna provide a value whenever you're gonna give.
Mm-hmm.
OP type is the specifier that you will be using,
Mm-hmm.
because OpenUSD you have to use the value types and all those specific things.
Mm-hmm. I see. USD Geom defines the 3D graphics related prim and property schemas that together form a basis for interchanging geometry between digital content creation tools in a graphic pipeline. So, what is this? USD Geom defines 3D graphics related prim and property schemas. Okay, that okay. So, USD Geom X form is part of USD Geom Imageable, and okay. All classes in USD Geom inherit from USD Geom Imageable. Okay. So USD Geom defines 3D graphic. Okay. Changing. Okay. All classes in USD Geom inherit from USD Geom Imageable, whose intent is to capture any prim type that.
And I
What?
would consider the USD Geom would be a base class and an abstract class because it
Yeah,
is inherited.
USD Geom Imageable is the abstract class and base class, and USD Geom is another abstract or base class, and I think USD Geom Xform is what inherits from USD Geom. Bro, wait, I also have this one thing. Where is this API schema document or there is this very nice API documentation. There is a diagram which is really nice. API documentation diagram. Where is it, bro? Toolset, FAQ performance. So it used to be somewhere over here. USD API documentation diagram. Uh, Wait, I'll show you over here in the video. I saw it in this guy's videos. Mm, 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 mm. Yeah, this one. Where is this fucking USD geomex formable?
Look at the
Uh,
link. What? Look at the link in the URL.
I'm not able to see the link over there. Uh-huh. Okay, so this is OpenUSD.org X form USD Geom X marble class reference. fucking APIs? USD Geomex formable. Is that? Yes, finally. What the fuck? Oh my god, finally.
You got it.
Yep, look at this. USD schema base,
Main
USD typed schema, USD geom imageable, which inherits in USD geomex formable, and then USD geom. Where is USD geom? USD geom is not here because I think all of them are called USD geom.
USD Geo will come from the main class.
USD geomex form over here. Look,
Yeah, but there is no USD Geo.
yeah. What is it saying? All classes in USD geom inherit from USD geom imageable. USD geom imageable. I think this is what USD geom is referred to as USD geomex formable. All geometry prims are directly transformable. All geometry prims are directly transformable. USD geomex formable encapsulates the schema for a prim that is transformable. Okay. USD geomex form is a concrete prim schema. USD geom X form is a concrete prim schema for transformation for a transform which is transformable and can transform other child prims as group. Other child prim as a group. Okay. So import PXR, import USD. Okay, okay. Mm-hmm. Bruh. It voided that question. Fucking I was right in that answer, so why did it void? But it's fine. I know that. Alright. And then this is okay. Create a new USD stage with root layer xform prim.usda file path asset xform prim.usda stage.usda USD stage equals to create new stage file path. Define a new xform primitive at the path slash world on the current stage world x USD geom.xform USD geom.xform.define stage slash world. Save changes to the current stage. Mm-hmm. So, resulting in this, XFORM prims are essential for defining and managing spatial transformations in a scene, making them indispensable for 3D, any 3D content creation workflow. Okay, XFORM API schema. XFORM common API. So, XFORM is the concrete schema, is a typed, and XFORM common API schema is a non-applied API schema.
Yes,
So,
that's correctly done.
XFORM Common API is a non-applied API schema of the OpenUSD framework. It is used to understand its utility in 3D content creation pipeline. This API facilitates the authoring and retrieval of a common set of operations with a single translation, rotation, scale, and pivot that is generally compatible with import and export into many tools. It's designed to simplify the interchange of these transformations. Okay. How does it work? The API provides method to get and set these transformations at specific times. For instance, it allows the retrieval of transformation vectors at any given frame or time code, ensuring precise control over the simulation process. There is another way to author and retrieve transforms through using geomex formable function. I see. Can you read this part?
Wait, I was looking at my thing in the study reference. Which para? Okay. The API provides, or the second paragraph, or the
No, no,
first
no.
paragraph.
Yeah, from first.
API provides methods to get and set this information at specific times. For instance, it allows the retrieval of transformation vectors at any given frame or time code, ensuring precise control over the simulation process. There is another way to author and retrieve transform through the USD geom expandable function. Expandable prim supports arbitrary sequence of transformation, which gives users a lot of flexibility. A user could place two rotation on a planet prim, allowing them to control revolution and rotation around two different pivots on the same prim. This is powerful but complicates simple queries like what is the position of object at time 101. This is another way to author through export function. Export supports arbitrary sequence of transformation. Okay, yeah, it supports arbitrary sequence of transformation, which gives power users a lot of flexibility. A user can place two rotation on a planet prime, allowing them to control revolution and rotation and two different pivots. This is a powerful but complicated simple queries like what is the position of object at 101. Okay, yeah. So yeah, it talks about like what are the different kind of operation that we can put in into our prim when we're trying to perform
Mm-hmm.
any form. So it gives a very good example as as we recall in our OpenUSD that
Mm-hmm.
you can have an object, and in that object you can create a rotation and revolution transform at the same time. But it becomes really difficult at what time, at like to find out at what time stamp or the time code which revolution or rotation is happening. So that is the only drawback it provides.
Mm-hmm.
Like it is possible, but without a simple query, like you have to really write a complicated query to get the exact values when you're trying to use these use exformable prims.
Mm-hmm.
And this is usually done by geom exformable, like the geom base class that we have.
I see. What the fuck? Materials and shaders. Hmm. Okay. There's another way to author and retrieve transforms. So, okay. There's another way to author and retrieve transforms through function, arbitrary sequences and transformations. It gives power users a lot of flexibility. Which gives power users a lot of flexibility. User could place, rotation of planet prim, allowing them to control revolution and rotation around two different pivots on the same prim. This is powerful but complicates simple queries like what position an object. Okay. This is the central contrast raw XFOM USD geom XFormable. Lets you stack an arbitrary sequence XFOM OP example rotations around different pivots, maximum flexibility, but resulting transform is hard to query or round trip. XFOM Common API deliberately restricts you to standard fixed set of components, translate, rotate, scale, pivot in a known order, so the transform is easy to interchange between tools. Mhm. Critical distinction, list order versus application order. Students confuse this. Okay, this is what we did right now. List order versus application order.
Students were us students confuse this.
Mm-hmm. The XFORM OP order attribute that XFORM common API authors XFORM OP equals to XFORM OP translate or rotate scale. That is the order ops are listed, but the order in which they are applied to a point is reverse of how you read the list intuitively. A point is scaled first, then rotated and translated in matrix P T R S P. The rightmost matrix S multiplies to the point first, and then leftmost translate is applied last. So list order is TRS. The application order is scale, rotate, translate. Describe the same configuration. Do not read the list left to right as the application sequence. Correct. This example verifies prim compatibility with XFORM Common API and demonstrates its use. Okay, from Pixar import USD geom. Okay, stage create new example.usda. USD geom.xform.define. Yes, check if xform common API is compatible with prim using the bool operator. If not, xform common API, USD geom.xform common API prim. Raise exception, prim not compatible. So this is attaching the xform common API to the prim. This is applying it. And if it is not able to apply, it will raise an exception, right? Over
Which
here,
part?
this part.
Okay. So if it is not able to apply, raise. Yeah. It will raise an exception.
Mm-hmm. Okay, set transformation. So this is setting translate, rotate. USDGM common API rotation order XYZ. This is setting scale. These functions demonstrate how to apply translations, rotations, and scaling to a 3D object using XFORM common API. You can get a transformation matrix from XFORMable prim that works with any XFORM OP order. Um, Okay, we can get a transformation matrix from the XFormable prim that works with any XForm OP order using get local transformation method. Okay. Um, these functions demonstrates how to apply translation. Okay, blah blah blah. Okay, we can get a transformation matrix. What does this mean? Get local transformation method. I think this could be a question. We can get a transformation matrix from the XFormable prim that work with any XForm OP order
Using the
using get local transformation method. This is how you obtain a single composed local to parent matrix regardless of whether the prim was authored via XForm common API or a raw arbitrary OP stack. Hmm. Do you get this?
yeah, like the local transform. It's gonna give you the matrix. You get a matrix for the translation that we saw earlier. Operation OP stack. Is it there?
No. In this diagram,
Yeah.
what? USD geom what?
The get local transformation.
No, why would it be here?
I was just wondering when they
This
have to
is
wake up to
typed
all.
schema, bro.
Is a type schema?
Bro, this is all typed schema because they are inheriting from USD typed.
I see.
API schema base is the one from which the API schema would applied API schema or non-applied schema would.
Hmm.
I'm gonna wake up at probably 10.
Okay.
Yeah, bro, we're gonna stream till 3.
Okay.
We're gonna stop at 3. Hard
Okay.
stop at 3. Okay, XForm Common API is convenience API for common transforms. It gives you clean Python. Okay, instead of doing XForm star attributes manually maintaining XForm pre-order, OpenUSD describes it as API for authoring and retrieving a standard set of component transform, scale, rotation, scale, rotate, pivot. Its goal is better component wise interchange while limiting the allowed ops and specifying their order. Normally, to move an object in USD, you need attributes like this. Uh-huh. Double X form, OP, translate, float, transform, OP, rotate. Okay. XForm OP, API. XForm common API lets you author through Python like this. You need to attributes like this. Mm-hmm. TRS means it is not applied schema. Okay, it is a non-applied API schema. Okay, remember this, bro. This is a non-applied API schema.
X form common. Dude, any I think. Wait, no. Applied API schema
Fuck
and
no.
applied non-applied API schema.
You will not be able to distinguish.
Okay. I thought I
If
was
it
gonna
is,
mnemonic. I was trying to see
uh,
API. All right. So I was gonna go with that, but then I remembered applied schemas each and every applied schema or any API schema has API in the back as
yeah.
compared to type schema. So XFAM
The
common.
only way you're gonna find out is if it is present in the metadata like this, prepend API schema is equal to this, then it
Yeah.
is an applied schema. But for this, it will not be present. It is saying that mean it does not write this.
I think I would say that any schema that is typed schema and is a
Mm-hmm.
part of abstract schema like USD geom is
Mm-hmm.
a abstract and is a type schema, I would say.
Yeah. Yeah.
So that those API schemas are non-applied schemas because you cannot make changes to them.
But they are not part of USD Geom. They are not coming from USD Geom, bro.
But USD geom xform common API.
But they
No,
are
I
not gonna come from, bro. What?
but
What are you
but I'm
saying?
saying wait, let's ask AI over here.
Yeah, ask it if XForm common API. Wait, I'll show you XForm common API as well. I think it should USD. Yeah, look at this. USD schema base, USD API schema base, USD Geom XForm common API. It is coming from API schema base. It is not coming from typed schema. Anything with an API in its name is not gonna come from the USD typed.
I see. If this kind of question comes,
I will use
that
it.
list which of the schemas are non-applied,
Yeah. Then
then
we'll just
I'm just gonna say
metadata.
no. There won't be any. I think in that scenario, I think there won't be any. How would I say?
Bro,
Source.
non-applied schemas are also API schemas. They are not just typed schemas.
Oh yeah. Oh yeah. Oh yes. But they can be typed schemas, right? Or not?
Bro, API schemas cannot be typed schemas. Look at this diagram, bro.
Dude, look at USD Geom X formable. Dude, it's a typed schema over there. If you look at the camel case
Yeah,
pattern.
so
So typed
this is
schemas are
not an
always
API schema. This is not an API schema.
USD Geom X formable is not a API schema.
No,
What is it? Non-applied API schema.
it's it's not a non-apply. It's not an API schema. It's a typed schema.
But is it a API schema or not?
No, it is a schema, bro. Anything with which is gonna be a US.
And what about XForm common API? Is
That
it's a
is, bro. Look at this. Look at this. USD schema base, USD API schema. Look at this diagram first, right?
no, that's fine. But
You
I'm just
and
talking.
that is where USD Geom Xform common API is coming. Xform common API is USD Geom Xform common API.
Typed case. Let me just verify this once. Because the way you would define a typed schema is by also looking at how they are. No, they are not. Do not import a type name. Okay, yes, they are not ever. Just wanted to verify this.
Yes, bro. I was showing you. Look at this USD schema base, right? Are you looking?
Yeah, USD schema base.
And then
And
it
then
is a USD API schema base is inheriting from this,
mm-hmm.
and USD Geom Xform common API is inheriting from USD API schema base, right? So this is one, and then in this diagram, USD schema base again. This is USD typed. So this is like a different branch, and this is like a different branch.
I see. So over here then USD GeoMX from common API is not a typed schema.
No, bro, no, not at all. An API
Yes.
schema cannot be a typed schema at all.
Yes. Yes. I got it.
So
Got it.
XForm common API is a non-applied API schema, preprint API schema. Okay. Basic Python usage, stage.usd, XForm. Oh, there is a rotation order as well. Damn.
Rotation.
X there is a rotation order as well, like rotation XYZ, rotation XZY, YXZ, YZX, ZXY,
Euler
and
rotation.
Euler
Hmm.
rotation orders.
Use geom.x from common API. OpenUSD. Okay. What is the rotation order thing? Students
Rotate.
make
Okay, what it means rotates, and there's a pivot as well. Other than rotate, translate, and scale, there is pivot
pivot,
as well.
pivot, pivot. You remember, friends, that episode?
I know.
Yeah. Pivot, pivot. Dude, I used to binge watch Friends. Now I don't know. My life has gone so dull. It's
Yeah,
only USD and Claude code.
yeah. I used to watch Big Bang Theory and Friends when I was like in ninth, 10th. And then I'm just like so over it now. I can't even tolerate it because it's like I can't even laugh at those jokes anymore.
Mm,
At one point they used to be funny, but now it's
the life is so
there is always Big Bang Theory playing in my gym. Like either there is like FIFA or Big Bang Theory playing in my gym for some reason. Mm. From PXR import USD GF, yes. Conceptually, this creates a stack like translate, translate, pivot, rotate, linear, translate, move back from pivot, move to pivot, rotate, scale, move back from pivot. Yes, okay. Reading the values back, you can also use XOM component to retrieve component values. Okay. Yeah, I want to take a look at what this is now. What the fuck is get local transformation method? Example 1, transform and inheritance. In this example, we use XOM common API to translate, rotate, and scale a parent. I think we should take a look at it over here. XOM common API. Oh, there's a whole fucking video. Are you able to hear it?
No. But I will just take a look at what are the visuals. I'm not able to. I'm able to hear something, but not clearly. Translate, rotate, and scale. Pivot. Time code. But this video won't be explaining the I think the get local thing.
Let me see. Component transformations, including scale, rotation, scale, and rotate. Abhishek is in the chat. He's saying Sui. Let's go,
Mm.
Ronaldo. He scored two
Yeah.
goals today. Two goals.
Oh, nice.
Yeah.
You betting?
Brace. What?
You betting?
No, bro. I don't bet on soccer. I
Uh,
don't. I'm not a subject matter expert on
I
soccer.
told Tiger. I told Tiger, bro. I think it's time. Like
Bro,
the I.
soccer is not that predictable.
I said to him that I think we need to come up with a strategy. Like you can just.
What is an RFE?
You don't know RFE?
It's like something
Request for
extra
evidence. Request for
evidence.
evidence.
Yeah, yeah, yeah. Evidence. Correct.
Yeah, when you do shitty things, and the USCIS thinks that hey, I think we need more evidence about your petition, because whenever you apply for something like for even for STEM OPT or H1B, it's like a
Mm-hmm.
petition that hey, this is why we want to apply for this visa, or and all those things, and this is our goal. And then they will just go through your file, look at your backlog, that what have you done till now, and you will say hey, yeah, these are the things that I have done and completed successfully. And usually it goes pretty fine until unless you're really doing some shady things. Like the company is known for mechanical engineering, and you're putting software engineering stuff on it, so
Mm-hmm.
that creates some kind of flags or something like that.
I see.
Yeah, like one of our friend was really worried about it, but you know, because he always does shady things, shady king. He he tries to keep himself safe, but what can we say?
Everything's gonna catch up, brother.
Yes.
All right. How does it go?
Dude, I'm planning to get this Apple Magic Trackpad.
Why
Uh,
the fuck would you want a magic trackpad when you have a keyboard and like you don't have a mouse?
I have a mouse, but this mouse is not doing that great of a job. So I'm planning, and it's going to be sleek for travel as well. Yeah, carrying a mouse is like a bulgy thing. I will think.
Bulgy.
I'm thinking. I'm thinking. And this, if I get a good eBay refurbished deal or something like that.
I see.
Like mouse is more for gaming, and I think gaming.
I have this mouse that I bought in 2021, I think.
Yeah.
2020.
Oh, that's the Logitech one.
Yeah, this one,
Oh,
Logitech. Oh, I think you've seen this. I had this in.
yeah. All
Bro,
right.
this mouse is so good. Like, it's still so good. That's
Oh
why I didn't
yeah.
get a new mouse. Yeah, this is still very good. Like, I feel so comfortable in using this.
Mm-hmm. Like the mouse I have is also good, but I'm trying to use my left hand more. So this mouse is more meant for right hand side. So
I see.
yeah.
Why do you want to use your left hand more?
Good. Because I have a muscle knot in my scapula, and like if because of the right hand movement, that knot gets irritated a lot. So AI has advised me that you should use your left hand more.
Oh my God, bro.
So I'm going, okay, all right, I will give it a try. And then when I'm trying to use this, it's like this. So my hand sits like this,
Mm-hmm.
and it's like really discomforting. But I'm able to use my trackpad easily, so that's why I'm thinking to get a trackpad, and it's going to be wireless as well. So
I
Apple.
see.
I'm going to get it from Apple.
I see.
I might go to Home Depot tomorrow to get a $100 eBay gift card with 5% cash back.
Yeah, tricks.
Tricks. So yeah, what did it talk about the get local transformation thing
I
or
didn't
not?
ask it yet. One
Yeah.
second.
Bro, OpenUSD. I don't know, man. We need. Did you look upon the Discord? Like, did you got any hints from the Discord that if people gave any hints that how difficult is the quiz?
No, they just
Like,
gave the
is
same old.
it difficult like this? The way we are doing it right now, like,
How would I know, bro? How would I know?
okay, well, fuck it, dude.
I think, but we prepared well. I am like confident.
We are prepared well, but the thing is, the problem is we are not prepared well enough. If they ask us something like way deep, like
Oh wait, okay. Somebody is saying on Discord, "Good luck, Shazam. The videos from the community office hours are really helpful. I wish I had them before presenting to the exam." Hey people, I am back to the NVIDIA community. It has been really intense month of work, so I'm happy to support if there are any questions about OpenUSD.
so. Questions from where?
The videos, office hours.
Office hours questions. Dude, yeah, holy shit!
I think
Isaac,
that same. No, no, no.
the
Those 6 videos, bro. I
oh,
think that's what he's talking about.
it
The 6 videos that I've already shared with you
yeah,
the
I know.
playlist.
Yeah, I know. But I'm just trying. Now I need. For tomorrow's quiz. Then that's what I'm gonna do for. That's
Yeah,
what
I'm
I'm.
also trying to get that transcripts from all 6 of those videos and then ask Claude to
How
create like a.
transcript of the YouTube videos. I think there might be something online that will help us definitely.
I know there is already, I already got the transcript for one video, but yeah, I didn't do it for all the videos.
We need to do it if there's a hint from that because that's gonna really help us. Mouse, partial transcript. Okay. Then you can use browser extensions like
Bro, there used
oh
to be some transcript thing on YouTube, but they removed it for some reason. This fucking assholes.
that's fine. I'm gonna wait. Where's the freaking playlist first of all? Okay. Developing and debugging. So that is the only playlist, or it has like 25 chapters over here. Oh no, this is a bullshit thing. NVIDIA customizing. Okay, this one. Okay, I'm gonna ask. Rude. I have to update my uh Roomba. Sorry, the robot cleaner's timing now. When I'm sleeping in the morning, it's gonna knock
Hmm.
on my door and then go back. Copy link address. Can you get the transcripts from the videos? These are the videos of OpenUSD office hours, and people have been asking questions in them regarding on these are the videos. And I got to know that.
One that OpenUSD will have similar questions.
Clean water in the station is insufficient.
Mm-hmm. Mm-hmm. Let's look at scope. The key takeaways from XHome Common API was provides the preferred way of authoring and retrieving standard set of components transformation including the goal of the API is to enhance Alright, the goal of the API is to enhance, reconfigure, or adapt each structure without changing the entire system. This approach allows for flexibility, customization, focusing on individual parts. All this is done by limiting the set of allowed basic operations and by specifying the order in which they are applied. Understanding scopes is important as they help in organizing and managing complexity in large-scale 3D scenes. What is called special type of frame that is produced for grouping mechanism and scene graph. It does not represent the geometry or renderable content itself, but it acts as a container for organizing other prims. Oh, think of scope as an empty folder on your computer where you organize the files. Similarly, scope helps in structuring, organizing prims within a USD scene. Prims are used to create a logical grouping of related prims, such as which can be particularly useful in complex scenes with numerous elements. For example, a scope might be used to group all prims related to material, animation, geometry. Key feature. A key feature of scope is that they cannot be transformed. Okay, so this was the question. The key feature of the scope is it cannot be transformed, which
Yes.
promotes their usage as lightweight organizational containers or transformable shell prims, such as geometry prims, will be evaluated correctly from within the scope prim and down the hierarchy. What does this mean?
Such a geometry will be evaluated correctly from within the scope. Within the scope that so you can define a scope, but you cannot transform the whole scope. So is there a code base over here somewhere? Uh,
This,
no, no.
look at
Yes, yes,
this.
yes. Yeah, this one, right? Yes. So you have def scope, like the
And
first,
then
like
there is X form
there,
OP
there,
translate
yes,
inside
you can
scope.
you can you can put transformation inside
Mm-hmm.
another frame,
Mm-hmm.
but you cannot put any transformation in scope frame. You get it? What I'm saying?
What? What?
So you create a scope frame.
Yeah.
Right? You have created a scope frame B scope.
Yeah.
right? Inside that prim, you are creating two more prims that are
Yeah.
going to be cube, right?
Yeah.
Now you can individually put transformations on those b cube 0 and b cube 1.
Individually put transformations on B cube
b
0
cube
and B cube 1. Okay, yes.
1, but you cannot put any transformation on b scope directly.
Yes. Yes.
So like for if it would have been another prim, let's say a sphere prim or a
Yeah.
box, right? And you want to basically rotate the whole box, you can do a transformation on that as well, so that any object inside the box will also rotate with it. You
I
understand what I'm
see.
saying?
Yes.
but
Yes.
but
But you
right now,
cannot apply it on a scope.
yeah, directly.
Yeah. All transformable child prims such as geometry prims or exons will be evaluated correctly from within the scope within and down the hierarchy. Thus, organization aids in simplifying scene management, making it easier for teams to navigate, modify, and render scenes. This is the key contrast with XFORM. And XFORM groups and transforms its children. A scope groups without transforming. Putting XFORMable children under scope does not break or zero out their transform. They still evaluate correctly. The scope simply contributes no transform of its own. Working with Python, USD geom.scope define stage path scope. Prim is a USD geom.scope. Example define a scope. Scope is grouping primitive and does not have transformability. It can be used to organize libraries with large number of entry points. It is also best to group actors and environments under partitioning scopes. Besides navigating, it's easy for a user to deactivate all actors or environments by deactivating a root scope. We can define a scope using USD scope.define. File path asset stage creative world container world equal to USD geom.xform define. Okay, stage world. So number nama. Okay, okay. Scope B scope. Populating. Okay, so active node active is equal to false on a scope. Okay, we deactivates it and the entire subtree beneath it. Oh, is an efficient way to prune everything organized beneath it for more active versus inactive frequency, active versus inactive lesson. Okay, so but I have a question. So if this is a def XFORM world
Mm-hmm.
and the
Where
scope
is,
is defined over here.
yes.
And the scope is defined under this.
Mm-hmm.
Like,
uh, mm-hmm. A
so,
scope, a
eh,
scope.
yeah, we if we apply some rotation or translation to X form world,
Mm-hmm.
it will work, right?
Yes, it will work.
But it will not work just on this scope alone.
No, wait. What do you mean by that? Like, what do you mean by the second question? Not alone. Like, it depends where are you trying to apply. That is the most important thing. So, if you put the XFORM operation order above the def scope, right, it will work. But if you put it after def scope A, like after the curly brackets you have and above the def sphere A, it won't work because you are applying that transformation on the scope.
What?
You get it? You get it or not? Wait. Okay. All right. I'm gonna explain you with example. Look at my camera.
Yeah,
Right. Wait. You look cool. Wait.
yeah.
What the fuck? Okay. Hold on. Right. So yes, this is your X form.
Mm-hmm.
This is your complete X form,
Mm-hmm.
right? And you're trying to create a scope inside this.
A scope
right?
inside this.
Yes,
Correct.
now we can define this scope as let me get another tissue paper. Yeah. So this is a this is another scope,
Mm-hmm.
right? Now you have the scope folded inside this.
Mm-hmm.
For the outer world, if you
Mm-hmm.
keep this is
Yeah.
a completely, this is a XFOM wrap
X
that is
form.
wrapping the
Yeah.
world, XFOM wrapping the scope.
Yeah.
Now, if you want to put any transformation on this XFOM, it
Mm-hmm.
will transform. It will basically, you say, hey, I want to scale up. Or
Mm-hmm.
if you want to translate on Y axis, so it's
Mm-hmm.
going to go up with the scope,
Mm-hmm.
everything inside it. So now you would say that, hey, why is the transformation getting applied onto the scope as well? Because
Mm-hmm.
scope is part of the world. So if you move the whole box with the world, the scope will
Mm-hmm.
move with it. That is one
Okay.
of the properties of OpenUSD. Now, now let this is the world. I'm going to keep the world aside. I'm just going to
Yeah.
scope,
Scope.
right? Right now, in this scope, you have a sphere.
Yeah.
You are putting this ball as a sphere
Mm-hmm.
over here. This is the
Mm-hmm.
sphere, and now it's wrapped into the scope,
Yeah.
right? Now, once you wrap this ball into the scope, now if you want to do any translation, you
Mm-hmm.
cannot do any translation because
Mm-hmm.
it is not wrapped. But you can individually do any translation. Now, let's say the scope is
Inside the
like
scope.
inside the scope. So now you can do the translation or
Mm-hmm.
rotation or
Mm-hmm.
anything like this inside the scope.
I
But
see.
now, let's say since there are two spheres, we will
Mm-hmm.
put another object. You have this as well,
Mm-hmm.
right? You have this sphere and this bottle.
Mm-hmm.
You cannot do any translation like this, but you
Mm-hmm.
can individually rotate, revolve, or do any operation on this. So you
I
can
see.
move this cylindrical object on x-axis along and this sphere along y-axis individually, but they will
I
remain in
see.
that scope
I see. I see. Okay.
like this. Yes, yes.
Def X form parent prim. This
So
is
as you can
commonly
see,
being scope.
as you can see over here, I'm gonna show you again. Go back.
Wait, this is the scope. Okay. So X form world is rotatable and transformable. Okay. But scope A, sphere 0, and scope B. Okay, so this is false, but only B cube. So, okay. Okay, I get it. Yeah, what are you saying?
No, nothing. Yeah, that was the same thing I was gonna show you, but yeah.
Mhm.
All right, bro. It's 3 a.m. We can keep carry on this, but we got other life as well.
Yeah. I think, yeah, we are done with scope as well.
Yeah, scope is like critical concept, but only like but one
Mm-hmm.
of the fundamental basics as well. So yeah, I think we might get a question from scope. I'm just gonna assume, and Claude is working
Mm-hmm.
on getting the transcription somehow. I'm just gonna do auto mode and blindly trust Claude code because
Mm-hmm.
fuck yeah, why not?
I see. Yeah.